today we will just, before moving on to files, which I cheated a little bit and not, like with our advent of code, we already moved on to files, but let's take a look at some functions that are useful when dealing with I/O, input output. Alright. Put string is much like put string line, but in that it takes a string as a parameter and returns an I/O action that will print that string to the terminal. Only put string doesn't jump to a new line after printing out the string, while put string line does. Alright, so ln just adds a \n on the end, which makes sense. So we put the string just wherever, and this puts a string and adds a new line after printing out the string. Yeah, that makes sense. Hey, I'm Andy. Its type signature is put string into, and we return an empty IO action. Yeah. So the result is, oh, actually, let's try to remember this. Type signature is put string, we get a string, and then an IO box. Right. So the result encapsulated within the resulting IO action is the unit, a dot value, so it doesn't make sense to bind it. Exactly, it doesn't return anything of value. Put char takes a character and returns an IO action that will print it out to the terminal. That seems like a... Why would you do that? Put a character instead of a string? That feels like... a long time ago, back in the day, computers took a lot of work, and instead of making a string, which is oh so... what is it? It's oh so... bloat. Yeah, strings are bloat. Strings are bloat, so we only put characters. I'm assuming that's what's going on. Right. Put string is actually defined recursively with the help of put... Oh, right, since we have put character. Of course, put character exists so that put string can exist. Right, the edge condition of put string is the empty string. So if we're printing an empty string, just return an IO action that does nothing by return the dot value. If it is not empty, then print the first character of the string by doing put char, and then yeah. Then by doing put char and then print off them using put string. Right, put string returns. Oh, we box. No, that's not box. That word again. The IO action returns a dot value, right? Put string and empty list, we return nothing because that's when we're done. And otherwise we just do a... oh, it's a do thing. So we put character, then we recursively put... Exactly. See how we can use recursion in I/O. Yeah, this is so easy to understand when you come from... Sorry. From different imperative programming languages. This is how you normally do recursion, right? Just like we can use it in pure code. Just like in pure code, we define the edge case and then we think what the result actually is. It's an action that... Hey Walker, stop doing that. Sorry. Just messing around. Colgate do not have asks for a quote. The quote is, we should use logical thinking to think logically. That is true by definition, isn't it? True by definition. Doesn't mean anything. Cat is really messing around. Can you just... Dude. Getting pissed as well. Angry cat. Calm down, dude. Alright. Alright, print. Oh, here we go. That's what I was asking for the other day. Print takes a value of any type that's an instance of show. Meaning that we know how to represent it as a string. Calls show with that value to stringify it and then outputs that string to the terminal. Basically, it's just put string line with show. Oh, so why haven't we been using print? Alright, because if we have strings, we don't have to put print. Oh, that's what I've been doing though, right? I did it like this, but with the $sign, put string line and then show. It is better to just type out print. First runs show on a value and then feeds that to put string on a new line, which returns an IO action that will print out our value. Good. Wait. The colors here has got to be broken, right? That's not really supposed. These would all be... Yeah, it depends on your terminal, I think. Because Vim doesn't have the same, usually not the same color setup as the rest of the terminal. Oh, right. This is actually a valid thing to point out, right? If you have a string, it will point it, write it out together with the double quotes. So if you actually have a string, you would want to use this. But for everything else, you would use print. Everything that is not a string, that is what you print out. Is a little bit annoying, but see why it has to be that way. Yeah. As you can see, it's a very handy function. It is, yeah. Remember how we talked about how IO actions are performed only when they fall into main or when we try to evaluate them in the GHCI prompt. When we type out a value like 3 or a list of 1, 2, 3 and press the return key, GHCI actually uses print on that value to display it on our terminal. Look at that. Well, Gitana says, depends whether you want to print. Oh, the double quotes. Yeah, right. But usually when you print a string, you wouldn't want to do that, right? Well, sometimes. Good point. Yeah, depends on. Sometimes you would want to print it, but most of the time you wouldn't. You'd just want to print the actual string. The value of the string, not the double quotes. But of course there are situations. Cat hair all over the place. Alright, when we want to Alright, exactly. When we want to print our strings, we usually use the put string on a new line because we don't want the quotes around them. But for printing out values other than other types to the terminal, use print is used the most. Right, the same is like if we... now that I think about it, right? Because we've done stuff like this, where we join strings together, right? Well, sometimes we put strings together with a double plus, right? To make a... to join two strings together, right? It would be more efficient, right? If we're only doing output with prints, it would be more efficient to just put string and then another put string call on the other string, right? Since we can do that in our do, yeah. Put string the first string and then put string the other string, right? When we're just... if we only care about output. Because it would be extra work to actually create a new string joined together instead of just printing the two separate strings, if we do have two separate strings. Or maybe the optimizer just knows what we're trying to do and fixes this for us. So it might not matter, but it might. Get character is an IO action that reads a character from the input. Thus, its type signature is get character and then an IO character. Because the result contained within the IO action is a character. Note that due to buffering, reading of the characters won't actually happen until the user mashes the return key. So it will probably read the last character. Skywalker, what the fuck? Stop. Dude. He's in a mood today. Right, so if we would have typed like, hey, we would return the Y character, probably, right? Main do C is get character. If C is space, then do put character C. Alright, print it out. And this program looks like it should read a character and then check if it's a space. Yeah, if it is. Alt execution. Wait. If it is... Alt print out to determine. No, it doesn't at all look like that. It looks like then do we put the character C, right? If you press space enter, then it will print another space and then it will return until it gets another character. Then it stops. Right? And do the same thing over and over again? Well, it kind of does, only not the way you might expect. Check this out. Hello, sir. Oh, I missed that one. If it's not a space. That's what confused me. I was like, what is going on here? Right, if the character is not a space, then we put the character. Oh, they actually... That I would not have expected, yeah. I would have expected that this would print O. Only O. Because of buffering, right? Because we get C is our character. When we press enter, we would have gotten... No, we would have gotten R. Yeah, I would have thought it would have printed R, because That's what we bound our C to, right? We bound our character to R. Right, the second line is the input. We input hello sir and then press return. Due to buffering, the execution of the program will begin only when after execution of the program will begin only when after we've hit return and not after every inputted character. But once we press return, it acts on what we've been putting in so far. Try playing with this program to get a feel for it. Alright, so because of buffering, and since we're doing our main call, it actually calls it on age because of buffering. So if we wouldn't do... Actually, I need to try this. Yeah, I need to check this out. Play around with it. Wow, we got a lot of stuff here. Do we have like a test? Yeah, Vim test. What's all this? Do we need any of this? No. Oh shit. Copy that. What if we have this here, but instead of doing this, we just do that? And oh, what was it? Haskell run? Was that it? CD. And we just did Haskell run. Run Haskell. There we go. Run Haskell test. And then we say hello. Yeah, exactly. It prints the percent sign. I don't know where the percent sign comes from. What's... oh. Oh. I don't know where that percent sign is coming from, but for whatever reason it shows up. However, if we do like they told us to and just recursively we say hello, it prints all of them. Yeah. It's just something specific with the percent sign there, but and the space. All right. Get a feel for it. All right. The when function is found in control.monad. Another mention of the monads, eh? When function is found in control.monad, to get access to it, do import control.monad. It's interesting because in a do block, it looks like a control flow statement, but it is actually a normal function. It takes a Boolean value and an IO action. If that Boolean value is true, it returns the same IO action that we supplied to it. However, if it is false, it returns the empty return action. So an IO action that doesn't do anything. Here's how we could rewrite the previous piece of code in which we demonstrated get character by using when. Right, we import control.monad. We do see get car when when this returns true, we do this all stuff. Otherwise, yeah, we automatically, because we have do, it will return Oh, that's our when. That's our when statement. Right, exactly. When it's false, it returns this. Interesting. So, see that again. It returns the same IO action that is applied to it. So it returns this. No. Yeah, it returns this. Same was confusing. So as you can see, it's useful for encapsulating the if something, then do some IO action, else return. This whole pattern we can encapsulate in a when statement. If this is true, then do this. Else. Right. Yeah, it's equivalent to just in other languages. Sometimes you do if statements, but you don't have an else. But since in Haskell we have to do an else, they do that with a when statement. Sequence take a list of IO actions and return an IO action that will perform those actions one after the other. The result contained in that IO action will be a list of the results of all the IO actions that were performed. Its type signature is sequence, a list of IO actions, and returns an IO list of actions. Coolgitinotab says, of course Haskell uses monads. It's the best of all possible languages after all. Oh man, I don't know about that. Isn't the best language assembly? If we're, well, we're not talking about natural languages here. I would have supposed that like a mathematical notation would be the best language in your opinion, Coolgitinotab. Just before I check that, I want to see. Alright, so doing this. A, get line, B, get line, C, get line. And then we print ABC is. Oh, right. RS. Right. That makes sense. If we want to create a list of our things. Yeah, a sequence. Sequence of events. What's this? The best of all possible worlds. Now we're thinking with utopia, aren't we? The phrase the best of all possible worlds, then for some reason we have it in French and German, was coined by the German polymath. Polymath? An individual whose knowledge spans a substantial number of subjects. And why is math here? You know, to me that seems like you know a lot of math. Different types of maths. I suppose math binds them all together. The Enlightenment philosopher Leibniz in 1710 work his Essence. Right, he was writing in French, of course. Essays of Theodicy on the goodness of God, the freedom of man, and the origin of evil. Claim that the actual world is the best of all possible worlds is the central argument in Leibniz's Theodicy? Or his attempt to solve the problem of evil. Theodicy? This is something I've missed in my philosophy education. Coolgitinotab says it was my feeble attempt at humor using an analogy between Leibniz's monads and Haskell's monads. Wait. Was it Leibniz that did the monads? I'm terrible with names. I thought it was another dude who did the monads. Isn't it? That was confused me. I'm terrible with names, calling it in on tap. That's why the joke just went like this. I'm sorry for the sidetrack, but I want to hear, what does this? Theodicy means vindication of God. It is to answer the question of why a good God permits the manifestation of evil, thus resulting in the issue of the problem of evil. Oh, right. So he says that this is the possible... The world we live in is the best of all possible worlds because God is good. That's his argument. Since God is good, this has to be the best possible world that exists. Oh man. Oh man. That is rough. It feels like I just got... what's that word? I feel gaslit. Yeah. I feel gaslit by this. Yeah, this is gaslighting on a philosophical level. Holy shit. That is fucked up, dude. That is fucked up. Right. Colgate on tap says, yeah, Leibniz did monads and calculus. He was a hard-working fella. Yeah, I mean, hard-working, like, doesn't necessarily mean that your work is any good, though, does it? Right? Yeah, he was hard-working at gaslighting the world. That was his goal. Seems like quite the douche. Yeah. Quite the asshole. Ooh, that was rough. Ah. Alright. Where were we? So... Yeah, so I don't know about the polymath. He was probably good at maths. I don't think philosophy was his strong suit. Maybe that's just... hindsight is 2020 and all that. So back then, maybe that philosophy made sense to people. Actually, I understand why it would make sense to people. I shouldn't do strawman the argument like that. It's just, to me, it seems like such utter nonsense and kind of rude, to be honest. To be honest? Oh, yeah. I felt gaslit. Tap says, maybe your monads are just out of place to see its geniusness. Wait, geniusness? Alright, a common pattern with sequence is when we map functions like print or put string line over lists. Doing map print 1, 2, 3, 4 won't create an IO action. It will create a list of IO actions because that's like writing print 1, print 2, print 3, print 4. Right? Yeah. If we want to transform that list of IO actions into an IO action, we have to sequence it. Right, so this won't work. Right, because we've created a list of actions. We don't actually do the actions. We have just created a list, and a list of these actions. Right, that's why we do the sequence. And the sequence is actually doing these actions. Okay. Oh. We return this. Hello, Coleman. Nice to see you again. How are you doing today? Yeah, what's with the empty returns at the end? Well, when we evaluate an IO action in GHCI, it's performed and then its result is printed out. Oh, right, we're in GHCI, that's why it's happening. Coleman says, I finally memorized how to finish that one puzzle in Portal Stories. Mel? I've never memorized a puzzle in my life. No, I have. Well, not intentionally memorized anything like that. I have remembered when I've redone it. That makes sense. For the 4 years I've played it, I could never remember how to do it. Oh, and now you've memorized. And I've always had to use a walkthrough. Ah, there we go. I think I have it remembered finally. I've never been interested in that myself. No, I would prefer just going back to the walkthrough if I got stuck. I think I would, however, remember even if I didn't intentionally memorize it. Yeah. I remember when I solved, for some reason that made me think about when I solved the Rubik's Cube. Yeah. And, right, I solved it, and then I solved it a couple of times just to make sure I knew how to do it. But I couldn't do it today just out of hand because I don't enjoy memorizing stuff for whatever reason. Interesting. What were we at? Yeah, that's the result. It will not be printed out. That's why evaluating put string length in GHCI just prints out because the contained result in the string is this is the dud. But when we do get line GHCI, the result of that IO action is printed out because the get line has a type of IO string. Exactly, right, yeah. Oh. That's a sneeze. Colgate in on tap says, I couldn't solve the Rubik's Cube. I think maybe you didn't solve the Rubik's Cube in on tap, but I am definitely sure that you could solve the Rubik's Cube, yeah. Yeah. I think your mind is better suited than mine. I think it took me like 3 days, something. And when I say 3 days, I'm not talking about what, 72 hours? No, but like it definitely took me more than 10 hours. Probably more than 15 hours. Maybe somewhere around 15 hours to solve the Rubik's Cube. Holy shit, I was bored. Yeah, it was when I was in New Zealand and we had nothing to do. We're just hanging out at the beach, I think. Yeah, we were hanging out at the beach and there was nothing going on, nothing happening. Just hanging out in a beach, and I wasn't in the mood to read any of the books I had, so I just sat around with a Rubik's Cube. Coleman says, the thing that I forgot, when I go from the first room to the second room, portal that I have put in the first room was still there. In my mind, I have always thought that it just disappears, even though in reality, there's nothing that actually removes it. Oh, it's a trick. That's, yeah. It's easy to get tricked by a trick, right? Yeah. Right, where are we? Because mapping a function that returns an IO action over a list, then sequencing it is so common, the utility functions mapm and mapm underscore were introduced. Mapm takes a function and a list, maps the function over the list, and then sequences. Mapm underscore does the same, only it throws away the result later. usually use map m underscore when we don't care what the result of our sequenced IO actions have. Right, so for printing we do this one, right? Wrong, Skywalker. Really not in a good mood today. Yeah, so we toss it away because we don't need it. Forever takes an IO action and returns an IO action that just repeats the IO action it got forever. Right, so it's like a while loop. While true loop. It is located in the control monad, and this little program will indefinitely ask the user for some input and spit it back to him. Caps locked. Right, we gotta spit it back caps locked. That's super important. Give me some input, get line, and then we just do it again. Oh. Right, since we don't want to... I mean, we could just add a line, but we wouldn't have to do forever do. We could just add a line that just said main, right? You just call main, and it would do it forever as well. So it feels... I don't know. For M, oh. Thought you said that there are no for loops. This looks like probably a for loop, doesn't it? Located in control.monad is like map M, only that it has its parameters switched around. Okay, the first parameter is the list, and the second one is the function to map over that list, which is then sequenced. Why is that useful? Well, with some creative use of lambdas and do notation, we can do stuff like this. Okay, what is this? Main do, we say that colors... Oh, right. Just change them around because we want to do all of this stuff. So have our lambda function within we do... Put the string, which color do you associate with a number? And then show A. I'm confused. A is going to be 1, 2, 3, 4. Color get... Yeah, we get the line and then we return the color. That's something that confuses me, that I feel still I don't really get that. We have a lambda function here that takes A, and then we show A, which I assume is the numbers, right? It doesn't become clear to me that A are these numbers, or why they are defined as A. Right, because we're mapping. There we go. Right. Because we're mapping. Mapping we do on each item on a list. Therefore magically whatever we put here is in our lambda function is gonna be the item in the list when we do mapping. Right, I guess it kind of makes sense. Just difficult for my mind to get that, I suppose. Right, and then the colors you associate with 1, 2, 3, and 4 are, and then we just Right, print out all of the stuff. The lambda a do is a function that takes a number and returns an IO action. Sure. We have to surround it with parentheses, otherwise the lambda thinks the last two IO actions belong to it. That wouldn't be good. Yeah. Notice that we do return color inside the do block. We do that so the IO action which the do block defines has a result of our color contained within it. We actually didn't have to do that because getLine already has that contained within it. Doing color getLine and then return color is just unpacking the result from getLine and then repackaging it again. So it's the same as just doing getLine. Oh. Okay. The for_m called with its two parameters produces an IO action whose result we bind to colors. Colors is just a normal list that holds strings. At the end, we print out all those colors by doing map_m put string on new line and a new line on the list of colors. Sure. You can think of for_m as meaning make an IO action for every element in the list. Yeah. What each IO action will do can depend on the element that was used to make the action. Finally, perform these actions and bind their results to something. We don't have to bind it, we can also just put it away. Okay, dude. We could have actually done that without for_m, only with... We could have actually done that without for_m, only with for_m it's more readable. Normally we write for_m when we want to map and sequence some actions that we defined. Map and sequence some actions we define there on the spot using do notation. In the same vein, we could have replaced the last line with for_m colors. And yeah, with string. In this section, we learned the basics of input and output. We also found out what IO actions are, how they enable us to do input and output when they are actually performed. To reiterate, here we go. IO actions are values, much like any other value in Haskell. We can pass them as parameters to functions, and functions can return IO actions as results. What is special about them is that if they fall into the main function or are a result of a GHCI line, they are performed. And that's when they get to write stuff on your screen or play yakety sax through your speakers. Each IO action can also encapsulate a result with which it tells you what it got from the real world. Don't think of a function like put string on a line as a function that takes a string and prints it to the screen. Think of it as a function that takes a string and returns an IO action. That IO action will, when performed, print beautiful poetry to your terminal. There we have it. Function returns actions, they don't do things. There we go. Because functions are things in a functional language. They don't do things. Actions, however, do things. We can return our actions. Man, this is a difficult language. How long is this files and streams thing? Probably... let's do this next time. This feels like a good spot to end and maybe continue with the advent of code for a little bit. Right.